Hello everyone and welcome back to Diksha Karnataka YouTube channel, and you are watching KCET 60 out of 16 physics series, where we are discussing all the chapters, also all the previous year question papers from that chapter, and everything will be completed within 100 days. So if you are new to the channel and if you are watching this video for the first time, I have two requests for you. First of all, click on the subscribe button so that you don't miss on any of the updates that we are doing in this channel. And secondly, you must join our WhatsApp group. The link is given in the description below. There we are sharing whenever we are uploading a new video, new topic from any subjects, whatever we are covering for KCET 2025 exam, everything, every update will be shared on our channel. Also, during weekend we are covering one mock test every week for each subject. So don't forget to join our WhatsApp channel as well, where you will get all these updates including the question paper for your weekly test. Now today we are going to discuss current electricity previous year questions. We have already completed current electricity chapter, so it's time to go through all the questions which are there in the previous year questions. We will be discussing 30 questions from previous year questions. Also, some of the questions that we are going to discuss may be out of syllabus. I will mention that this is out of the syllabus so that you get an idea. Okay, some of the questions which maybe I am finding difficulty to answer actually are not part of the syllabus. That's why still some of the out of the syllabus are going to be discussed here. They are maybe important for JEE if you are preparing for JEE, because in JEE, even though they are deleted from your books, even though they are deleted from KCET, they are still there in JEE. So you may be required some assistant to answer those questions, but afraid not. For KCET, those difficult questions, which question you might be finding difficult, are not part of your syllabus. So we are going to discuss that as well. Now let's start with the first question. For a given electric current, the drift velocity of a conduction of electron in a copper wire Vd, and their mobility is mu. When the current is increased at a constant temperature, Vd remains the same. Now you should remember that Vd is given by NEA, sorry, not Vd, I is given by NEA Vd. Now that means Vd is basically proportional to current. Okay, Vd is proportional to current. So if current increases, Vd also increases. Now interestingly, mobility is given by Vd by E. Okay, now when current increases, Vd increases, fine, E also increases. So this formula is not very efficient to give us an idea. There is another formula which also is there. Okay, tau by m. Now here mass is tau E by m. E and m. Okay, E is the charge of an electron, m is the mass of an electron. They are constant, right? And tau is the consecutive time between two consecutive collisions. So electrons are colliding with each other consecutively, and that time between, basically you can say, like you have done in mean free path, the path traveled by gas molecule between two collision. Similarly here it is time. Okay, here it is the collision time. Okay, average collision time between two collisions, whatever time is taken, that is given by tau. Now this tau depends only on temperature, right? This temperature, this depends only on temperature. Now if temperature is constant, then we can say that mu will remain constant. Mu only depends on temperature. So mobility of a substance of a conductor depends only on temperature. It is independent of the current. Okay, so Vd increases, but mu remains the same. So correct option is option D, where it says Vd increases, mu remains the same. Question number 2. 10 identical cells of each EMF 2 volt and internal resistance 1 ohm are connected in series with 2 cells wrongly connected. So all of them are connected in series, but 2 of them are wrongly connected. So what is the meaning of that? So suppose I have, this is the basic connection. Like that we have 8 resistors. Like this, we have 8 resistors, all of them are connected like this, but in between somewhere there are 2 batteries which are, or 2 cells which are connected wrongly. Wrongly connected means they are connected in opposite polarity. They are connected in opposite polarity. So what will happen? Suppose total, how many cells are there? 10 identical cells, right? Out of that, 8 are properly connected. So what is the equivalent EMF? Equivalent EMF should be 8 of them are connected properly. So 8 times EMF of each of the cells minus those 2 are wrongly connected. Okay, that is the equivalent EMF. So EMF of each cell is given as 2 volts. So it will be 8 times 2 minus 2 times 2. So it will be 16 minus 4. So 12 volts. So 12 volt is the equivalent EMF. Now it does not matter how you connect the cells, resistances are always added. Resistance can never be subtracted. Resistance will always be added. So 10 cells, each of EMF, internal resistance 1 ohm. So the equivalent resistance will all be added. So it will be 10 R. So that is 10 times 1, that is 10 ohm. Right. Now a resistor of 10 ohm is connected to this combination. What is the current through the resistor? What is the current through this resistor? Current will be simple formula, E minus E divided by capital R plus R equivalent, that is epsilon. Epsilon is 12 volt. Divided by 10 ohm externally connected, 10 ohm is the internal resistance. So it will be 12 divided by 20. So it will be 0.6 ampere. So correct answer is option B. Okay, simple. More practice you are doing, it will be better for you for your final exam. So you have to practice. There is no other way, and this is the most important chapter. So you have to answer as many questions as possible. Now this is very interesting question. The equivalent resistance between the points A and B in the following circuit. So this is an infinite circuit. If you see, this is an infinite circuit. Now to answer such question, what we have to do? We have to break this circuit. How we can break this circuit? To break this circuit, first of all, we will consider where it is repeating. So if you see, if we cut this circuit from this point, okay, and if you see, there are 2 ohm, 2 ohm, 2 ohm, 2 ohm, and then infinite resistance, right? Similarly, here also 2 ohm, 2 ohm, 2 ohm, and infinite resistance. So basically, what we can say, if the equivalent resistance of the entire circuit, that is the equivalent resistance between A and B, say R, small r, I am assuming small r. Now, if you cover this part, if you see, this is also same, right? So equivalent resistance between these 2 points will also be smaller. This is the trick that you have to remember. This is a specific trick, and this kind of problem is very common in either JEE or NEET. Okay, this also will be R. Why? Because this is an infinite circuit. So if you see from here, you see the entire circuit that has a resistance R. From here, if you see, okay, if you cover this, you will see the similar thing, right? You will see similar thing exactly the same way from if you start from A and B. So the equivalent resistance between these 2 points is also R. So now what we will do, we will draw this circuit as this 2 ohm is here, this 2 ohm is also here, this 2 ohm is also here, and the rest of the circuit is basically a repetition. So what we will do, 2, 2, 2, and I assume the entire resistance of the circuit is R, and because of the infinite circuit, infinite repetition, we can consider this also as R, right? So we can write this as parallel combination R with this 2 ohm resistance, right? So what we will do, we will now try to simplify this. This entire resistance is again R, right? So what is the equivalent resistance of this? Equivalent resistance is R, right? We have assumed R. Now what is the value of R? First of all, these two are in parallel. So these two are in parallel means, what is the equivalent resistance? Equivalent resistance will be R times 2 divided by R plus 2, right? That is the law. R1 R2 divided by R1 plus R2, as long as they are only two resistances. Now this is the equivalent resistance for this part, and these two are in series. So it will be 2 plus this. All the three resistances are in series. So this is the value of R. So this also R. This is also R. This is little bit difficult to understand. If you are practicing and if you are understanding the concept, then you will be able to understand. If you are not practicing, maybe you will not be able to answer this question. So 4 plus 2R divided by R plus 2. Now we have to take this value in one side and we have to simplify it. So R minus 2R divided by R plus 2 equals to 4. Now we have to simply solve this equation. So how we can solve this? Let's do the cross multiplication. So it will be R into R plus 2 minus 2R equals to 4R plus 2. Okay. Now simplify it. R into R, R square, okay, plus 2 into R, 2R, okay, minus 2R equals to 4 times R, 4R, 4 times 2, 8. Okay. So it will be 2R, 2R cancels. So what we get? R square minus 4R minus 8 equals to 0. This is the equivalent resistance equation. Now we have to simplify this equation. How we can simplify this? So to solve this, we will use Pythagoras theorem. So R equals to, so we will use Pythagoras theorem. First is minus b. Minus b is already there is a minus, so minus of minus 4. So it will be plus 4, plus 4, plus more minus b square. B square is 4 square minus 4 whole square, that is 16, minus 4ac. 4a is plus 1 and c is minus 8 divided by 2a, right? 2a is 1 here, right? So this is the formula. Now let's calculate the value. So it will be 4 plus or minus 16 plus 32 divided by 2, okay, or 4 plus or minus 16 plus 32 is 48. Now resistance value cannot be negative. So if you see 48 is very close to 7. We will in fact assume this value as 7 because it is 49. Assuming 48 almost equals to 49, we will be able to solve this problem. Now if we consider the negative value, negative 7, then it will be 4 minus 7 minus 3. Resistance cannot be negative, right? So negative resistance is not possible, so we will not consider the negative sign. So we will also consider this 48 to be 49, so that we get 4 plus 7. Okay. So 49 means square root of 7, so divided by 2, so 11 by 2. So the answer will be 5.5 ohm. Little long and a little longer equation, and unfortunately based on this problem there is no such shortcut method available, because if they give you 5 ohm, the equation will be different. If they give you 4 ohm, the equation will be different. But for 2 ohm, if they repeat this question, you should know the answer will be 5.5. Okay. Now, the resistance of a carbon, so let me mark the correct answer. So, correct answer is 5.5 ohm. The resistance of a carbon resistor is 4.7 kilo ohm plus minus 10 to the power plus minus 5%. The color of the third band is. Now, in this question is no longer part of your syllabus. You should know there was a color code of resistances. Color code of resistances is no longer part of your syllabus. So, if you see any color code related questions, you can avoid that. But for this question, you should how you can solve this. So, basically third color means this is not required, only thing required is the resistance. So, 4.7 kilo ohm means 4.7 times 10 to the power of 3 ohm, or the way we write is 47 times 10 to the power of 2 ohm. So, this is the first color code, this is the second color code, this is the third color code. Okay, this is how we write the color code. So, 2 is stands for red, so red is the correct answer. Okay. Now, the 4 bands of color coded, again color code questions which is not again part of your syllabus. Color coded resistors of the colors gray, red, gold and gold. Okay, now gray is 8, gray means 8, okay, red means 2. These things, there used to be a formula that you need to remember, that no longer needed. Gold is a specific color for third part, it is used for -1. So, it will be 8T2 times 10 to the power of -1 ohm, and fourth gold means plus or minus 5%. Okay. So, it will be 8.2 ohm plus or minus 5%. Okay. So, 8.2 ohm plus or minus 5% is the correct answer. Okay. Now, wire of resistance R is connected across a cell of EMF epsilon and internal resistance R. The current through the circuit is I. In time t, the work done by the battery to establish the current I is. A very interesting, confusing question. You might think, okay, what is the potential difference across the capacitor, across the battery? Then I have to use the formula vitamin VIT. There is another formula for power. If you remember, I told you for primary formula is VIT, right? Now, VIT is applicable when you know V, okay, and if you can find V in terms of epsilon. So, epsilon V is basically epsilon minus IR. Now, if you see, none of the equation has small r, so you cannot use this formula. So, what you have to do, you have to use the alternating formula, same formula. If you put instead of V, if you put it I by R, sorry, if you put V equals to IR, okay, and times I times T, then you get I square RT. So, power that is exhausted is actually the work done. So, work done is the power, power is the work done, mechanical work done, mechanical power if you remember. So, to establish the current, the work done is given by I square RT, that is the formula. Okay. 10 identical cells of each potential E and internal resistance R are connected in series to form a closed circuit. An ideal voltmeter connected across 3 cells will read. Now, I have solved this question while solving my regular Kirchhoff's law and voltage law chapter. So, if you are not seen that video, go and watch that. Current electricity part 3 released yesterday. There I have solved this question. I am going to solve it quickly now. So, what it is said that 10 identical cells each connected. Now, there is nothing is incorrectly wrong, and in fact, the question is this is a bonus question because all the options given in this question were wrong. Okay, but I will solve it quickly. There are 10 such cells are connected. Okay, and it mentioned that you have connected a voltmeter like this. What will be the voltage? Now, they are connected in series. Okay, they are connected like this. Now, what is the current initially when they are connected? When they are connected initially, the current was all the sum of the battery, that is 10 epsilon, divided by all the resistance, that is 10 R. So, it will be epsilon by R is the current. Now, what is the voltage across these three batteries. Voltage across these three batteries will be these three cells rather 3 epsilon naught minus 3 I R, right. So 3 epsilon minus 3, value of I is epsilon by R times R. Okay, so it will be 3 epsilon minus 3 epsilon is equal to 0. 0 volt is the answer, but now that option is not given here. So this is a bonus question. This was a bonus question. This question came in previous year. So that question was considered as bonus question. Now, in an atom, electron revolve around a nucleus along the path of radius 0.72 angstrom, making 9.4 into 10 to the power 8 revolutions per second, the equivalent current. So in 1 second, the electron revolves these many times. Revolutions per second means one electron moving in a circuit, okay, they revolve in how many times it revolves. Okay, so how much charge passes through, suppose I consider a surface here, small surface area here, how much current, how much charge passes through this surface area in 1 second, that is the current, right. So how we can do that? We know that current is basically Q by T, right. Now here this information is not required, this is just an extra information to confuse you. So here number of revolution per 1 second times charge that is it is carrying in 1 second, so that is the current, right. Time is already 1 second, so instead of writing T you can simply write 1. Okay, now what is N? Number of revolution per 1 second, that is 9.4. 9.4 times 10 to the power of 18. Okay, and current E is 1.6 times 10 to the power of minus 90. Now remember that I always say do some approximation, do some approximation. In this case, if you see, all the options are very close to each other. Okay, all the options are very close to each other, so even if you do some approximation, it has to be very, very smart, right. So what approximation I do? If I do approximation, say if I do approximation and say this is 10, okay, if I say this is 10, then the closest answer will be 1.5. Okay, but you cannot be sure, and if you are doing it incorrectly, you might be confusing between, okay, 1.4 or 1.5, which one is the correct, because we have increased the value to 10, then it can be 1.4, it can be 1.5. So what we will do, we will reduce the value to 9, okay, and then we will multiply, okay, so that we can remove one possibility. Let's see what will be the value. We know if I increase it to 10, we will get 1.6, right. 16 times 10 to the power minus 1 means 1.6. So mostly from here I can assume the answer will be 1.5, but let's verify it with 9 times 1.6. Okay, 9 times 10, 1.6 times 10 to the power minus 1. So 9 times 9 is 9. Okay, 5 6 are 54. It will be 144 times 10 to the power of minus 1. So correct answer is 1.44 times is the answer, that when we are getting it, when we are reducing 9.4 to 9. So if you are reducing 9.4 to 9, that means if you use 9.4, mostly we will get the answer 1.5. Okay, this is the closest answer, because while calculating this, we have reduced the value, actual value. Okay, so when we put the actual value, the answer should be more than that. So more than that means 1.5 is the correct answer. Okay, this is another way of doing approximation. When a metal conductor is connected to left gap of a meter bridge is heated, the balancing point. Okay, now you should remember that meter bridge is no longer part of your syllabus. Okay, so when metal conductor connected in the left gap of a meter bridge, now you should know what is the left gap, what is the how the meter bridge works. So all the functions you need to remember that. Okay, so a meter bridge works like this. There is a conductor here, there is another conductor here, okay, resistor basically, then there is a meter length, and generally they do the balancing like this. Now if this left gap, this is the left gap resistor, if this is heated, then what happen is this resistance increases. This resistance increases means this works on the principle of Wheatstone bridge. So what we have to do, we have to adjust the current by shifting the meter bridge towards the right. So shifts towards the right or towards the center. Now this is very confusing. It can be towards the center. If it was here, then it will shifting towards the center. Okay, if it is here, it shifts towards the right. So both are correct. Okay, so I will not answer this question. I will leave it to you. You do the research, answer this, because this is no longer part of your syllabus. Okay, a charged particle is moving in an electric field of 3 times 10 to the power of minus 10 volt per meter with the mobility of 2.5 times 10 to the power of 6 meter per volt second. The drift velocity is, now I already told you mobility is given by Vd by E, right? So drift velocity will be mu times E. Now mobility is given, okay, and electric field is also given. So very simple, 3 times 2.5, that is 7.5 times 10 to the power of minus 4. Okay, so 7.5 times 10 to the power of minus 4 is the correct answer. Simple. Wire bound resistors are made up of, this is a very general knowledge type question, and the correct answer is constantine, nichrome and manganese. Okay, so you don't need to worry about too much about this question. If this question comes, you have to do the logical thinking that germanium, gold, gallium, okay, they are basically semiconductors. AU is not semiconductor, germanium and gallium are semiconductors, so basically this is not. Okay, Cu, Al, Ag, they are very good conductors, so you cannot create resistors using good conductors. Okay, now again in the fourth option, silicon, this is I don't know what is Tu, and for iron, they are also good conductor, so they are also is not possible to make bound resistance. For resistance you need high resistance material. So high resistance material, you remember the term nichrome, okay, manganese and constantine are also high resistance material. That's why they are used in bound resistance. Okay, so you can use your head little bit, try to understand the question first. What is the meaning of that? Bound resistors means something related to resistors. Now that part is no longer part of your syllabus. Resistance boxes, resistance box, it was there in your syllabus, so I think this question is also out of syllabus. If voltage across a bulb rated 220 volt 100 watt drops by 2.5% of the rated value, then the percentage of the rated value which the power would decreases. So we know that I solved this question in the past also. If you have not followed this, the question is the solution was there in the chapter where we had discussed power and energy. In that part 2, I think you can check that. Okay, so P equals to V square by R, right? P equals to V square by R. So dP by P equals to 2 delta V by V. R is constant. Okay, now what is happening? Voltage is changed by 2.5%. So basically delta V by V is 2.5. So what is delta P by P? So delta P by P will be 2 times 2.5% equals to 5%. This is a way of solving it. I explained this while teaching this topic. So if you have missed that, go back and check this. Okay. Now, a wire of certain material is stretched slowly by 10%. Its new resistance and specific resistance will be. Now, wire of length. So wire of length initially was L. Now it is increased by 10%. So increased by 10% means new length will be 1.1 L. Increased by 20% means 1.2%. 1.2 times. Okay. Now I told you what is the formula to remember, that final resistance is basically change in length times by times. So how much times it is increased? 1 times, 2 times the factor. Okay. So the factor by which it increased, say the factor is k, so k square times old resistance. Okay. So it increased to 1.2 times, right? 1.1 times, sorry, 1.1 times, because it is increased by 10%. 10% means 1.1. So 1.1 whole square times r, so it is 1.21 r, and if you see only one answer is correct, that is 1.21, and specific resistance, that is resistivity, depends only on temperature, it does not depend on anything else, so it will remain same. Okay. I even told you how you can answer this question without even doing any mathematics. That was also there. Okay. So if you forgot that, you can check that. Now, question number 14. A wire of resistance 3 ohm is stretched to twice its original length. The resistance of the new wire will be. So, R final will be, what is the increase? Increase is twice. So, factor K is 2 here. 2 square R initial. So, 4 times 3, that is 12 ohm. Okay. 12 ohm is the correct answer. Now, how I achieved this formula? For that, you have to check my lecture where I have discussed and I have derived this formula. This is only we are solving PYQs. In some critical cases where some mixed concepts are coming, I will be explaining the formula, explaining the theory. Otherwise, I will not explain the theory. If it is already explained during the lecture, you have to go and check the lecture. Okay, now here, in the given arrangement of experiment, a meter bridge, if AD corresponding to null reflection of the galvanometer is x, what would be the value of radius if the wire, if the radius of the wire AB is doubled? Answer will be x. Okay, now meter bridge is completely deleted from your syllabus, so I am not going to explain why this will remain x. Okay, if you are interested, you can go and check. A copper wire of length 1 meter and uniform cross sectional area 5 times 10 to the power of minus 7 meter square carries a current of 1 ampere. Assuming that there are 8 times 10 to the power of 28 free electrons per meter cube of copper, how long an electron will take to drift from one end to the other? So, first of all, what we have to do? We have to find the drift velocity. Okay. So, how we can find the drift velocity? We know that I equals to N E A V D. Okay. So, first of all, we have to calculate V D. So, V D is equals to I divided by N E A. What is I? I is 1 ampere. What is the density? Density is 8 times 10 to the power of 28. What is E? E is 1.6 times 10 to the power of minus 19. What is area? Area is 5 times 10 to the power of minus 7. Okay. Now, if you calculate, what will be the value? So, VD will be equals to, so 5 times 1.6 is 8, and 8 times 8 is 64, right? And 10 to the power 28 minus 19 minus 7. So, 28 minus 19 minus 7, it will be 10 to the power of 2. That is 1 divided by 6400. So, this is the drift velocity, right? So, drift velocity is calculated and they have given the length of the wire as 1 meter. So, S equals to the metal rod of length 10 centimeter and a rectangular cross section of 1 centimeter cross half centimeter is connected to a battery across an opposite faces. The resistance will be. So, what is the thing? You have a rod, okay, and it is not circular cross section, but it is a uh, rectangular cross section. Now they have said maximum, where which 2 point the resistance will be maximum. Obviously the resistance will be maximum when they are connected between these two plates, right, where area is minimum and length is maximum. So in this case, so what is the area of this? This is 1 cross half, this is 1 cross say 10, this is half cross 10. Okay, this one is half cross 10. Any one of them is half, one of them is 10. 1. So just for example I am writing. So answer will be maximum when the battery is connected across 1 centimeter times 10 to the power half centimeter faces. Okay, 1 centimeter cross half centimeter faces. That is the answer. You have to understand. This is just a language question. Okay, nothing much about calculation, nothing much about uh, any difficult concepts. Only thing is you have to identify the surfaces where it is length is maximum and area is minimum. So area is minimum in these two cases and length is maximum in these two cases. Okay, so this is the answer. Now, a car has a fresh storage of battery of EMF 12 volt and the internal resistance 2 times 10 to the power of minus 2 ohm. If the starter or the motor draws a current of 8 ampere, then the terminal voltage. Simple problem. I think I solved this question as well. V is equal to epsilon minus IR. Okay, and epsilon is given 12 volt. Current is given. Current is drawn by the motor as 80 ampere. And internal resistance is given 2 times 10 to the power of minus 2. Minus 160 times 10 to the power of minus 2. So 12 minus 1.6. Okay, so it will be 10.4. Okay, 10.4 volt is the answer. Okay, now this problem also I have solved during my regular lecture. So let's solve this question. Suppose the current entering this say 3I. Now these three paths are equivalent. They all have the shortest route with 3 resistances. So current will be divided here equally. So this will be I, this will be I, and this will also be I. So current distributed equally through all the paths, because the path available for this current to pass from here to here to here, 3 resistance, 1, 2, 1 resistance, 2 resistance, 3 resistance. Okay, even if they go from this way, 1, 2, 3 resistance. Okay, similarly here also 1, 2, 3, or 1, 2, 3. So 3 resistance is the minimum path available. Okay, someone might say, sir, why you are not considering this path? Okay, that is 5 resistances, but that is not possible. Current always flow in a path where minimum resistance is available. That is the minimum law of minimum resistance. Okay, if I give you a very tasty food in front of you, and if I give you karelaka juice, what we will take? Will you ignore the tasty pizza or pasta, or you will drink karelaka juice? Obviously no, right? So you will take the pizza or pasta, right? Similarly, current is also like that. It also flows from minimum resistance. Okay, so current flowing in the minimum resistance, what we will do? We can say that the current is flowing through this equally. Now at this junction there are 2 paths and they are also equivalent. So current is flowing through this is I by 2 and this is I by 2 also, and they are all merging here. So I. Okay. Now what we will do? We virtually complete this circuit using some battery so that we can apply KVL. Okay. Some brilliant students, they don't need to do it. Okay, they can simply apply it. But for common students like me, I need to apply it. Okay, now if you consider this path, any one path, okay, here A, B, C, not B, say this is P, this is P, this is Q. So A, P, Q, B, A. Okay, this path. So in this path, what is the current in this resistor? Suppose all the resistances are smaller. All the resistances are smaller. I will use the value at the last stage. Okay. So in this path, what is the voltage drop across this resistance? I times R. So IR. Okay. What is the resistance across this resistance P to Q? I times I by 2 times R. Right? I by 2 is the current, R is the resistance. Now what is the voltage drop across this? Again IR. And here we are going in the opposite direction. So if the voltage drop is V, then that will be minus V equals to 0. That is the loop rule, right? So we have simply applied the loop rule. Now let us see the value. So I by 2, R, so it will be 2 plus half IR equals to V, or 5 by 2 IR equals to V. Now what we are going to do, instead of everything, if we replace the entire cube using an equivalent circuit. So we are replacing this entire thing using an equivalent circuit, and that equivalent circuit will only have equivalent resistance, the battery that we have applied, okay, and A and B. What was the current that we have applied? We said current passing through A is 3I and going out is also 3I, right? That is the current that we assumed. Now if you consider this circuit, okay, what is the Ohm's law? Okay, Ohm's law says that V is equal to IR. So V should be equals to 3I times R equivalent. So we simply write this value in our next equation. Okay. So what we will do, we will write 3I R equivalent. Okay. In my class lecture, I have solved this slightly differently, but later on I realized this is the shortcut way. So 3, sorry, not 3, 5 I by 2 divided by 3 I cancels, so 5 divided by 2 times 3, so 5 by 6. 5 by 6 ohm, because small r is 1. So what we have done, we also put the value of small r is 1 ohm, that was given. If it is any other value, then you have to multiply it. If the value of R say 2 ohm, then you have to multiply with 2 ohm. That's it. Okay, simple problem. So R equivalent is 5 by 6 ohm. Okay, let's check the answer. This is the answer. Okay. Now, a potentiometer has a uniform wire of length 5 meter, a battery of EMF 10 volt, and a negligible internal resistance is connected between its ends. The secondary cell is connected to the circuit given balancing the length at 200 centimeter. The EMF of the secondary cell is. Now this is also not part of your syllabus, but let's see how we can solve it. So a potentiometer of uniform wire of length 5 meter. Okay. A battery of 10 volt and negligible internal resistance is connected between its ends. A secondary cell is connected. So now this question is no longer part of your syllabus. Also, the data given for this problem is not correct. So even if you try, you will not get the answer. So the formula for this is potential gradient, that is 10 divided by the length, that is 5 meter, that means 500 centimeter, times the length, balance length, that is 200. Okay, it is 20 divided by 5, so it is 4 volt. 4 volt is given. So correct answer is 4 volt, but this is no longer part of your syllabus, so you can ignore this question. The color code for a carbon resistor of resistance 0.28 kilo ohm, 28 kilo ohm, again it is no longer part of your syllabus, but it is there in JEE. So I will answer this question. So 28 times 10 to the power 1. So 2 is red, 8 is grey, okay, and 1 is brown. So red, grey, brown. Okay, this is the answer. And plus minus 10% is silver. All the fourth option is silver, so don't worry about fourth option. Only thing you have to correct is which is the order: red, grey, brown. Okay, grey is 8, green is 5. Okay, green is not 8. IV characteristics of a copper wire of length L and area of cross section A is shown in the figure. The slope of the curve becomes less. Now, what is the meaning of this slope? First, let us understand the meaning of this slope. Okay, so you should know that we know that V equals to IR. Okay, and in this graph, I is plotted along y axis and V is plotted along x axis. So what we have to do? We have to write I is equal to V by R. We know that y is equal to mx plus c. So in this case, c is 0 because it is passing through the origin. In case they are passing through the origin, we can ignore the c, only y is equal to mx. Now comparing these two equations, y is I here, x is v here. Comparing this, we can write that slope of this graph is 1 by r. Okay, so if slope increases, resistance decrease. Resistance has to decrease. So if m is increasing, r has to decrease, and if r is increasing, m has to decrease. Okay, so it is an inverse relationship, right? So now let us understand what are all the possibilities. First of all, less. Slope becomes less. Slope becomes less means resistance increasing. So resistance increasing. Now what is the formula for resistance? Resistance is given by R is equal to rho L by A, right? So if resistance increases, then what are the possible causes? Resistance increases if L increases, if A decreases. So let's see what are the options. So less if the area of the wire increased. Area of the wire increased, so A increases, that means resistance decreases. Resistance decreases means slope has to increase. So this is not correct. Less if length of the wire is increased. Now less means slope is decreasing, so resistance has to increase. When you are increasing L, okay, so length of the wire is increased. Definitely this is correct. So length increasing means R is increasing. R increasing means slope decreasing. So slope is less. Okay, now let's check other two options as well. More if experiment is performed at higher temperature. At higher temperature, we know resistance increases. So resistance increases means slope decreases. So it is not more. Okay, more if a wire of steel of the same dimension is used. Now steel has less conductivity. Okay, so in case of steel, the resistance is very high compared to copper, right? Copper, silver and gold, these three are very good conductors. That's why we use silver and gold are obviously very costly. So that's why for our most of the wirings we use copper wires. Okay, and another very close to copper is aluminium, but it is still not as good as copper. Okay, so and steel comes much less. Steel has much lesser conductivity. So in case if you are using steel, the resistance increases. Resistance increases means slope decreases. Slope cannot be more. So these three options are not possible. Only possible option is option B. This is a little tricky question. You have to answer this carefully. Okay. Now question number 23. Through the electron drift velocity is small, though the electron drift velocity is small and electron charge is very small, a conductor can carry an appreciable large current. So current, we know that current is basically NEA VD. You need to remember these formulas exactly. Okay, then only you will be able to answer that. Now it is said that VD is very small. We have done mathematics, we have calculated that VD is very small. For example, today we calculated one problem, VD was about 1 by 6400. Remember that problem? Okay, so VD is very small value, right? In fact, charge is also very small. The charge of an electron is 1.16 into 10 to the power of minus 19. Then how can we have a very high current? So 10 ampere current, 20 ampere current. Okay, how can a wire which is carrying the current can carry say 1 ampere? 1 ampere is a very high current in fact. So if I say this wire is carrying 1 ampere current, in fact, if you see there are different plug points where the rating is mentioned 5 ampere plug points, 32 ampere plug points, 15 ampere plug points. So how they are able to withstand that much amount of current. So the actual answer is lied behind this value. Okay, area is okay, area is constant. Most of the cases area, you can increase the area to increase the current, but other option is because the value of current charge density is very high. Okay, it can withstand very high amount of current. So electron number density depends on the temperature, does not matter. Okay, electron number density is very large, obviously it is the correct answer. Relaxation time has nothing to do with this. Drift velocity of electron is very large. So in the question they are saying drift velocity is low, and in the option they have given drift velocity is large. So you have to be careful while answering such questions. So obviously n is very high, that's why it can withstand this much current. Now masses of 3 wires of copper are in the ratio 1:3:5, and their lengths are in the ratio 5:3:1. The ratio of their electrical resistances are. This is a very tricky question. It will take some time to answer. First of all, what is the relationship? We know that resistance is basically rho L by A. Okay. Now what is the volume of a wire? I have discussed this part. Volume is given by capital V. Volume is given by length times area. This is not voltage, this is volume. Okay. Okay, volume is length into area. Now what is mass? Mass is volume times density. Okay, I am using density symbol D, not rho, because then it will be completely chaos. So mass is given by density. Volume is LA time density. Okay, now let me find the value of A. Sorry, let me find the value of A in terms of L, because in the question it is given that their lengths are changed. So how the area is dependent on length. Okay, so let's say, so area is basically M divided by L times D. Okay, D is the density. Density is constant. Okay, now if we put the value here, you can calculate resistance as rho L by M by LD. Okay, so it will be rho L square D divided by M. This is the formula for resistance in terms of length and mass. You can remember this formula as well. If you remember this formula, then your life will be very easy to solve this kind of problem. But this kind of problem, as you see, came only once. Okay. Now what it says that R1 is to R2 is to R3, you have to calculate for given ratio of masses. Now if you see, R is constant, D is constant, only thing changing is L and M. So what we will do, we will see, we will write this as L1 square by M is to L2 square by M2 and L3 square divided by M3. Right. Now what is L1 is to L2 is to L3? L1 is to L2 is to L3 is this 5, 3, 1. Okay. Okay. So 5 square, okay, divided by length, mass is 1, okay, is to length is 3 square divided by mass is 3 is to, okay, length is 1 and mass is 5. Okay, so 25 is to 9 by 3 is to 1 by 5. So 9 by 3 is cancelled. So it will be 25 is to 3 is to 1 by 5. So you have to multiply everything with 5. So 125 is to 15 is to 1. So correct answer is option C. Be careful the order in which it is given. If you miss the order and if you apply the order, if you reverse the order for mass and length, then answer will be completely different. You will get answer as A, not C. So be careful, this is a little tricky question. Okay. Now, this is a very interesting question. I don't know whether this question was given by mistake or by a very clever teacher. Okay, so if you start from here, as I said, current always follows the path of minimum resistance. Okay, now current starting here, it has to go through this resistance. Okay, and it has to come back through this resistance. There is no other way. These two resistance path is fixed. Now, if current is passing through here, is there any other path available? Obviously, there are other paths available, but which path the current will take? Current will only take this path. Why this path? Because this is the path of least resistance. There is no resistance here. If you see, there is no resistance here. No resistance here means current will never pass through this resistance or this resistance or this resistance or this resistance or this any other resistances, because they all have higher resistance than zero resistance. This is zero resistance. So current will obviously will ignore all these resistances. It will only pass through this, but it cannot ignore this resistance and it cannot ignore this resistance, because this is directly connected to the end of the battery, right? So they has to pass through these two resistances, but these two, all the other resistances are optional. And in this case, because this is short circuited, this is called short circuited, so current will only pass through this point and they will not pass through any other resistances. Now, what is the equivalent resistance? Tell me the answer. Equivalent resistance is 1 plus 2, that is 3 ohm. Okay, so current will be 1.2 divided by 3, that is 0.4 ampere. Now they have asked you what is the current through this 2 ohm. 2 ohm is 0.4 ampere. This is obviously connected, and same current passes through all this resistance, and this common path. So it is 4.4 ampere. Okay. Now question number 26. Kirchhoff's junction rule is a reflection of this. I was taking the class yesterday, so that point of time I explained is Kirchhoff's junction rule, that is KCL, is conservation of charges. Okay, conservation of charges. It is not related to conservation of energy. Loop rule is conservation of energy. Junction rule is conservation of charges. Okay, the variation of terminal potential difference with current flowing through a cell is shown. The EMF and internal resistance of the cell are. This is also one of my homework problem. So as I said, in this point current I is equals to 0, and in this point terminal voltage is 0. Okay, so what we know, that at this point current 0 means V equals to epsilon equals to 3 volt. Okay, current is 0, right? At this point 0 equals to epsilon minus IR, right? So we will use that also. So epsilon is, obviously we calculated epsilon is 3 volt. Okay, so the potential difference is 3 volt. So 0 equals to epsilon minus IR, or IR equals to 3 volt. I is given as 6 ampere. 6R equals to 3, or R equals to 0.5. So 3 volt, 0.5. This is the correct answer. Okay. In a potentiometer experiment, the balancing point of a cell at a length 240 centimeter, on shunting the cell with a resistance of 2 ohm, the balancing length becomes 120 centimeter. The internal resistance of the cell. This is also no longer part of our syllabus. If you are interested, you can answer that question and let me know in the comment. Ohm's law is applicable to obviously a conductor. Okay, diode, for diode I have already discussed, it is not applicable. For transistor is also a type of diode, complicated diode, obviously it is also not applicable. Electrolyte, for electrolyte also Ohm's law is not applicable. Okay, the effective resistance of between P and Q. Okay, so they have asked you to find the effective resistance between these 2 points. This is all very simple question. So first of all, these two resistances are in series. So you start with the points which are directly connected. So these 2 points are directly connected. So we can say they are in series. So if they are in series, so that will be 3 plus 3, that is 6 ohm, and it is connected parallel to this, and then this 4 ohm resistance connected here, and a 5 ohm resistance is connected here. Okay, so what is the equivalent resistance of these two resistors? Equivalent resistance of these two resistors is 3 because they are equal. So equivalent resistance is R by 2. I mentioned this multiple times while answering. Next is 4 and other one is 5. So these all three are, as you see, they are in all parallel. Are they parallel connected? Series 4 plus 3 plus 5, that is 7, 7 plus 5 is 12. So 12 ohm. Okay, so 12 ohm is the answer. Simple question. So we have reached at the end of today's lecture, and if you have not yet subscribed to our WhatsApp channel or not yet subscribed to our YouTube channel, don't forget to join our WhatsApp group. Also subscribe to our YouTube channel. Thank you for watching.